Okay, so our next lesson, or transformation, is called rotations, which I always refer as the turn. So this one is about a fixed point called the center of rotation through an angle of x. Okay, so here it is. That maps a point to its image such that if the point is the center of rotation, then the image or pre-image are the same point. So what they're saying is C is going to be the same point regardless. It's the A that's going to move, and that's going to move the angle of rotation. Okay? If the point is not the center of rotation, then the image and pre-image are the same distance from the center of rotation, and the measure of the angle of rotation formed by the pre-image, center of rotation, and image points is x. So what they're saying, so this side and this side again are the same length. So let's see this in action. This one has rules, and I think the rules are going to be very helpful. So if you have a highlighter, I highly recommend it. Rotations are also counterclockwise. So if you're looking at a clock, it's going to go that way. Okay? So to rotate a point 90 degrees counterclockwise about the origin, here's the rule. So really this is called 90 degrees rotation counterclockwise, or it would be the same thing if you said 270 clockwise. Okay, I hope that makes sense. I'll show you a picture. I think I already did, but I'll do it here. So if you're going from here to here, that's 90 degrees. Or if you were going clockwise, you would be going 90, 90, 90, so it would be the 270. That's what it means. So make sure you kind of keep that in mind. A rotation that's 180 degrees is basically two turns. And the easiest way to think of those are these are 90 degrees. So if you go from here to here, here to here, that's 90. You would end up over here for 90. Over here's another turn, so that's the 180. So, and here's the rules. Again, I would highlight these. These are important. You're just changing those values. So it's the opposite of y, x stays the same. They just changed positions. The 270 rotation is the same thing as that's counterclockwise, or 90 degrees clockwise. It's the same thing. So there you go. Those are the rules. Next page. Make sure I have those rules. So for the rules, again, I'm going to stick with the rules because trying to do these without the rules is very difficult. You really have to have a good, what's that called? You've got to be able to have a good sense of direction, and not everybody has that. So work with the rules. So the 90 degrees, because that's what this one is saying, so 90 degrees counterclockwise unless it says otherwise, sometimes written like this. So I'm going to take each one of these points. You know me, I like to write down the points first. I'm a rules girl. And again, you can plot these, that's fine. I'm sticking with the rules. Okay, for 90 degrees, I'm going to give you the rules. It says you change your x, y to the 90 degrees rotation as you negative y, x. So I'm going to flip-flop it. So my L prime becomes the opposite of negative 1, which is positive 1, and the x stays the same. M prime changes to the opposite, so it gets tricky, the opposite of negative 4, which is 4, and then the x stays the same. My n prime says I'm going to, what is the opposite of negative 2, which is 2, and then that stays the same. And that would be a 90 degrees rotation. The next one is 270. So that rule is xy changes to y negative x. Okay. And I do like how they say you can multiply the x coordinate by a negative 1. So that's kind of another way to look at that. So we have P, Q, R, and S. Okay, so I need to multiply those, flip-flop the order, and then multiply the x by a negative 1, or just think of it as its opposite. So my 7 is going to be first, and the opposite of 4, or multiply that by a negative 1, is negative 4. 6 is first, negative 6. For some reason, this one is a lot easier. At least it is for me. All right, so that was super easy. Is that it for that? Yes, these transformations aren't too bad. This next one's a little weird, but that's tomorrow.